So for homework, I had you do some constructions. I had you start with a small segment and call that unit length, and then construct a bunch of different things from that. So what we want to study now is what is constructible and what is not. So we're going to use all the algebra that we've developed so far and those ideas that you may have gotten from doing the constructions to figure out what the answer to this question is. What can we construct with a compass and straight edge, and what can we not construct? So we're going to start this by thinking about a set F of all the constructible lengths. So a length is constructible if using just the compass and straight edge and starting with a unit length segment, I can make something of that new length. So for homework, you started with unit length, you made one of length 5, of 3, of 2, of 5/3. So we want to think about the set of all the lengths that I could construct. What does that look like? So in particular, if I could construct lengths A and B, what else could I construct? So if I knew how to make a length A and a length B segment, one thing that is pretty straightforward to make is length A plus B. And I do that by making a length A segment and then making a length B segment, setting my compass to that length and extending off the end of the A B more units. And so then I end up with a length A plus B segment. So what this is telling us is that F is closed under addition. If I know I can make length A and length B, then I can make the sum of them. All right, I can pretty easily make the difference also. So again, I would make a length A segment, and then I would make a length B segment, set my compass to that length, but go back the other way. And what I'm left with right here is length A minus B. So this is talking about subtraction, but the way we've been thinking about this is F has additive inverses. If I can make length B, if B is in my set, then minus B is in my set also. All right. One of the homework problems showed you if you know how to make length A and length B, then you can make the product. I think this was number 2, part A from the homework. So this is telling us F is closed under multiplication. Okay. And that involved some operations with triangles, setting up some triangles so that one length was A times B. Another construction that you looked at showed you how to make length A over B. I think this was number 2, part B, which tells us F has multiplicative inverses. Okay, so now all 4 of these together tell us that that set F of all the things that I construct, this is a field. We have closed under addition, closed under multiplication, we have additive inverses, we have multiplicative inverses. For homework, you made that length 5, length 3, and then you made a length 5 over 3. So those should have led you to realize that, in fact, you could make any rational length. I can make any integer length, and I know how to split that integer length up into another set of integer pieces, right? I took a length 5 and I split it into 3. So we know that Q, F. But one question that remains is what else? And the last piece of the homework showed you that Q isn't everything. It showed that we can construct, using, again, some triangles, the square root of A. If A was something that we could construct, then we knew how to make something of length square root of A. And this is new. This means it's not just Q, it's not just rationals we can construct, we can make other kinds of things. All right, so we want to explore this a little bit more. Let's think through one quick example of the kinds of things we can do. So closure under square root, the fact that if I knew how to construct a length A, I could make square root of A, means we can construct things like maybe square root of 1 plus square root of 3 minus root 5, some complicated thing like this. And the way I would do it, the steps that I would take, would be to first construct length 5. So I would make a segment of length 5, and then I would use that way to take the square root. If you look back at that construction from the homework, if we could make a length 5 segment, then through setting up some different triangles, we could make a root 5 length. Okay. From there, after I know how to make a root 5 length, I can set my compass to that long, and I can do 3 minus root 5. I can construct the length 3 minus root 5. Once I've got that, then if I know how to construct that, I know how to construct its square root by, again, setting up those similar triangles. Okay. Once I can construct that, then I can add 1 to it. That's no problem. I'm just going to take that length and add a unit length segment, and once I know I can do that, then I can take the square root of that. So step by step, we can make a that's that long. Okay, so any real number made from the operations plus, minus, times, divides, and square root, starting with a rational, is constructible. Okay, so if I can write down a number that I started with a rational and I just do a bunch of those operations in whatever order I want, that means I can construct that number. So we're going to figure out a way to write this down more formally, and then we're going to try to tackle the other direction. So what we're saying here is that if I can write a number in this way, then I know I can construct it. So then the question, the one that will be harder to answer, is if a number is constructible, did it have to be made out of these operations, or is there other stuff we just haven't seen yet? So we will get to that later.